Hi, I'm Lowery-Simpson, and I'm from In-Nature Robotics in Hanwell, New Brunswick. I'm here to talk about low-cost robotics, in particular our low-cost robot, AMOS. It's a little bit different from other robots you might see here at the Blue Innovation Symposium, in that it doesn't work out in the open ocean or in a really rough sea state, but it does excel in relatively calm coastal or inland waters. We hope that you'll find it interesting and that you might possibly have some application for it or our services.
Here is our AMOS Board Kit, installed in a small 6-foot foam surfboard. It uses an air propeller at its stern for propulsion, and this propeller is rotated by a servo to turn the boat. It has GPS and an inertial measurement unit for navigation, and is controlled by a Raspberry Pi computer with an attached camera at the bow. This sort of boat is light and easy to deploy by a single person, with a shallow draft that allows it to travel over vegetation or submerged equipment that could cause problems for propeller below the waterline. There are quite a few applications for low-cost robotic boats, but these are some of the ones that we're looking at initially. Universities and some high schools offer robotics programs that could use a boat like AMOS. It could also be used by university or government researchers performing surveys in lakes, rivers, or coastal waterways. A fleet of AMOS robots, with adaptations perhaps for the open ocean, could assist search and rescue by spreading out to cover a large area of water. An AMOS boat could be suitable even for a hobbyist budget in some cases, or might find application in areas currently unfamiliar with robots, such as recreational fishing. The higher-priced components of the AMOS Board Kit are shown here. The Raspberry Pi 3V Plus computer, a very capable ARM-based quad-core processor that can handle video, navigation, sensor data collection, and communication functions all at the same time, $65. A cellular 4G hotspot allows AMOS to connect to the internet using the Pi's Wi-Fi, $180. A lithium iron phosphate 12-volt 10-amp-hour battery pack for $150. For GPS position accurate within about 2 meters without differential correction, a survey-grade antenna and receiver board costs $350, and improved accuracy and precision are available if it's used with a base station. If only moderate, plus-minus 10-meter accuracy is required, a much lower-cost USB GPS receiver can be used. The AMOS Airprop has a drone motor and propeller mounted on a mast, rotated by a waterproof servo motor. $60. There are other components too used for communications, video, solar charging, humidity and temperature sensing, and sensing the orientation of the boat, but these are also low cost, in many cases less than $50. With everything put nicely together in 2 boxes for the AMOS Board Kit, you just need to add your own floating substrate to make an ASV for $1,735, and that's Canadian dollars, so way less in US dollars. The AMOS map-based software is intuitive and easy to use. Just click on the map for the points to travel to and collect sample data. You can hold down the P key while left-clicking to take one or more pictures at a point, and can then easily configure the heading directions for the photos. You can also hold down the S key while left-clicking to define safety points for the boat. These are points that AMOS would travel to if it encountered a problem. For example, if it detected that the battery was getting low and needed recharging, it would travel to the nearest safety point. Here are some videos of AMOS in action. The first of these is a fiberglass foam catamaran prototype with a 100-watt solar panel. It was moving down the St. John River near downtown Fredericton in July. These next clips show the AMOS Board Kit on the same foam surfboard that was shown earlier in the presentation. This was also filmed in the St. John River in Fredericton. It was in December, so considerably colder that day, but luckily not too much wind. Temperature, turbidity, pH, and dissolved oxygen sensors have been used on AMOS, and there are plans to add more. Here is some temperature data shown in the AMOS software and portrayed over a closed region using an interpolation routine. The Raspberry Pi has a number of digital inputs available, including a few USB ports, one of which was hooked up to an RS-232 USB converter and the NEMA 0183 output of a Humminbird fish finder to get depth data. And here is the interpolated view of that depth data. Dissolved oxygen data was collected from July to September over a couple of different sections of the St. John River and showed an expected drop in levels due to the warming of the water in late July and early August. And AMOS was able to mostly finish a geo-writing task this past summer, although this day was overcast and the boat ran out of battery power after a couple of hours, just before it finished the H.
The AMOS hardware and software has been developed and tested over almost 3 years. We believe the boat has a lot of potential and could enable many new customer applications. Thank you for watching this video. We'd love to hear from you. Please give us an email or a call or fill out the form on our website. Thank you.